In this video, we're going to look at simplifying square roots, okay, and we're going to look at whole numbers and variables. Okay, so simplifying the square root of whole numbers. What we need is we need at least one perfect square. Okay, so when you're taking the square root of a whole number, we need a perfect square somewhere. Okay, so if I look at this, the square root of 16, well 16 is already a perfect square and the square root of 16 is 4, because 4 times 4 is 16. So this would be an easy one. Alright, but if I look at, let's say, the square root of 132, okay, this is not a whole number. If I were to use the calculator and do the square root of 132, it's going to give me a number that's a decimal. But we are going to write our answers in what's called simplest radical form. So no decimals allowed. So what can I do with the square root of 132? I'm going to rewrite 132 as two different factors. Okay, and one of them must be a perfect square. So what that means is the square root of 132, I need two numbers that multiply to 132 where one of them is a perfect square. Okay, so what is a perfect square that could be divided into 132? Well, 4 is an example. So I'm going to rewrite the square root of 132 as the square root of 4 times 33, all right, because 4 times 33 would give me 132. And whenever I have multiplication inside a square root, I can break it apart. So this is the square root of 4 times the square root of 33. Okay, so I broke 132 apart into two separate factors, and one of them is a perfect square. Then all I'm going to do is simplify as much as I can. So the square root of 4 is 2. And the square root of 33, I'm going to leave as the square root of 33. Then the only other thing that you have to check is there any other number now that I could divide 33 by? Okay, so could I break 33 apart? Well, 1 times 33, but neither of those are perfect squares, and 3 times 11, but neither of those are perfect squares. So when there's no factor that's a perfect square, that's your final answer. All right, and then this next example here, I have 3 times the square root of 27. I'm going to do the same thing, okay? 27 I need to break apart into two factors, one of which is a perfect square. So what perfect square can go evenly into 27? Well, 9. So I'm going to rewrite this as I still have the 3 outside, and then I have the square root of 9 times the square root of 3, because 9 times 3 is 27. And then I'm going to simplify where I can. So I still have 3 here. The square root of 9 is 3, and then I have the square root of 3 out there. Okay, and I can multiply these two because now they're a whole number. So 3 times 3 is 9, so 9 square root 3. Okay, 9 square root 3 is the simplest radical form of 3 square root 27. Okay, so I did 3 of your examples from the bottom of the page. What I want you to do is pause here and finish the rest of them, okay, and then bring it to class and we'll go over the answers to all of them in class. All right, then we also have the square root of variables, okay. I'm going to show you a couple different ways you can think about this. So if I look at this, I have the square root of a squared b to the 4th c to the 6th, okay? So the first thing I'm going to do is I'm going to break apart each variable. So I have the square root of a squared times the square root of b to the 4th times the square root of c to the 6th, okay? And I'm going to show you a couple different ways that you can think about what we're doing here. The first way is just like you do with numbers, what's the square root of a squared? Well, it's something times itself that would be equal to a squared. That would have to be a. A times a would give me a squared, so the square root of a squared is a. Another way that you could think about this is square root. I could rewrite this actually as an exponent, and if I did, it would be to the 1/2 power. So roots become fractions when we write them as an exponent. Okay, then we would be using our laws of exponents. So b to the fourth to the 1/2 power. If I have a power to a power, I'm going to multiply them. So 4 times 1/2 is 2. So the square root of b to the fourth would be b squared. All right. The other way to think about this is if I have c to the 6th, I could rewrite that as the square root of c times c times c times c times c. 1, 2, 3, 4, 5. Oops, I need one more. Okay, so that's c to the 6th. C times itself 6 times. All right. Over here I had a squared. All right, when I took the square root of a squared, I had a. So what I could do is create pairs. So right there would be a c squared, right there would be a c squared, and right there would be a c squared. All right, so all of my pairs then, remember if the square root of a squared is a, then the square root of c squared is c. So I have, outside I would have c times c times c, which would be c to the 3rd. So the square root of c to the 6th is c to the 3rd. My final answer then here would be a b squared c to the 3rd. All right, so these all three are ways that you could think about this. There's also a little shortcut. All right, if you notice, a squared became a to the 1st, b to the 4th became b to the 2nd, and c to the 6th became c to the 3rd when we took the square root of them. Okay, so when I take the square root of a variable with an exponent, it divides the exponent in half. Okay, so 2 divided by 2 is 1, 4 divided by 2 is 2, and 6 divided by 2 is 3. All right, so that's another way to think about it, is dividing the exponent in half. Now, the dividing in half part, what happens if I have something like this where I have a to the 3rd, b to the 5th? If I divided 3 by 2, I would get a fraction or a decimal. And if I divided 5 by 2, I would get a fraction. I would get 2.5. Okay, you can't have fraction exponents. So here's what we're going to do. Just like with the whole numbers when we rewrote things as perfect squares, what I'm going to do is split the variables apart into one even number exponent and then just the leftover one. So I'm going to rewrite this as the square root of a squared times a, and then b to the 4th times b. Okay, so if I were to put it back together, a squared times a would give me a to the 3rd, and b to the 4th times b would give me b to the 5th. Okay, so I've created even number exponents. So now I have the square root of each of these pieces. So the square root of a squared, the square root of a, the square root of b to the 4th, and the square root of b, and I'm going to simplify what I can. So the square root of a squared would be a. All right, so I've done that one. The square root of a can't be simplified. The square root of b to the 4th is b squared, so that one's taken care of. And then the square root of b cannot be simplified. So what I'm going to do with that stuff that can't be simplified, I'm going to put it all together under one radical. And so this would be my final answer. All right, ab squared times the square root of ab. Okay, so here we go with one more example. All right, a to the 3rd, b to the 12th, c to the 9th. So again, if I have an even number exponent, I'm good. I can just divide it in half. But if I have an odd number, I need to split them apart. So I'm going to split this apart. The square root of a squared times the square root of a times the square root of b to the 12th can stay together because that's already an even number. C to the 9th becomes c to the 8th times c. Then simplify what I can. So the square root of a squared is a. The square root of a cannot be simplified. The square root of b to the 12th is b to the 6th. That's done. The square root of c to the 8th is c to the 4th. All right, and then what's left over goes in a radical, so square root of ac. And that would be my final answer. All right, again, I want you to try the rest of the examples at here on this page. If you have any questions, write them down, type them on the Google form, be prepared to ask in class on Friday.